Next, we're going to take a look at the clientless based SSL VPNs. We're going to see what is the use case, how does it work from a traffic flow point of view, and then of course the configuration steps, and then we're going to move to the actual configuration of a clientless based SSL VPN tunnel. Use case is that it brings flexibility, as we spoke before, for remote access VPNs. When the remote device is not managed and does not have a VPN client software installed and cannot even install a VPN client, either because the user doesn't have admin rights to install the client or because that company's policies prohibits installing any kind of clients on the PCs, then we have to, if we want to allow those users to fire up a VPN tunnel, SSL VPN tunnel, then they're going to have to make use of the browser. Because the browsers, as we know, when we browse our webmail accounts or whatever protected HTTP sessions, HTTPS sessions, the user is going to make use of a browser to fire up an SSL VPN tunnel with the ASA in clientless mode because it doesn't have a client installed. Now, the drawbacks of clientless SSL VPNs is that it does not provide full support for all IP traffic. I'm going to better understand that, the reason of that from the traffic flow point of view, and it does not support DTLS, which means real-time applications that is not supported through clientless SSL VPNs due to the proxying nature of this clientless SSL VPN. We're going to speak in a couple what the proxying nature means later on. Now, upon successful connection, the ASA is going to present to the user a web portal that users can click back and forth to access resources. So again, it's going to be just like your Gmail account. You connect to Gmail, you authenticate, and then you have access to your inbox mail, and you have a lot of options in there to change the settings, to send emails back and forth, whatever you want to do. The same thing in here, but of course the portal is going to look different because it has a different scope being for users to be able to access some resources to the VPN tunnel. Now, the traffic flow, let's speak about the proxying nature of clientless SSL VPNs. Because in clientless SSL VPNs, the remote access client does not get assigned an IP address because it doesn't have a VPN client installed to use that address. Then for that reason, from the traffic flow point of view, the ASA is going to act as a proxy device for protected resources. So what's going to happen? The remote client is going to click in the portal to access some resources, but then on the protected side of the network, ASA is going to initiate the traffic in the name of the user, so it's going to do proxy in the name of the user or the client. Like if you take the same example as before, with ASA3 being the VPN gateway and PC being the client, but this time it's going to run in clientless mode. Once the tunnel is being built, so the user ASA has, again, on this side the address of 136.1.37.16, the public address of the VPN gateway, and the user has that public address of it's not public, but assuming it's going to be public, 172.16. 96.0/24, 96.100. So what happens in the portal, the user is going to, let's say, click in order to access, let's say, the web server from router 4. So to this tunnel, we want to provide connectivity from that user to the web portal of router 4 to manage the router 4 via the GUI. Because the remote client, the PC, doesn't get assigned an address, what's going to happen is that through this SSL VPN tunnel, the user is going to click in the web portal of the ASA. So traffic flow from the PC to the ASA tree is going to be in the format of the payload, where in the payload the user says get HTTP, give me access to that web portal of router 4. That's going to be the payload. It's going to be an HTTP GET request, and the IP header. Of course, then we're going to have that inside TCP TLS, because the payload is being secured. It's not visible in clear text in transit. TCP TLS encapsulation, And then we have the IP headers, which is going to be the public addresses of the client and of the VPN gateway. So it's no more IP attached to the payload because the user doesn't have assigned an address in clientless SSL VPNs. So source is going to be the public address of the client 172.16.96.100, and destination is going to be the VPN gateway address 136.1.37.16. So this is what the ASA receives. It's going to remove the IP header, remove the TCP TLS headers, decrypt the payload, and then what's going to happen on the inside network, when the ASA actually is going to send that web request to router 4, this packet is going to look like this. It's going to be the payload, which is what the user wanted. Get HTTP traffic, get me the web portal page of router 4. And then the IP headers are going to be, source is going to be the ASA's address on this interface facing the protected resource. So that's why they state that the ASA is going to proxy in the name of the client. So in clientless SSL VPN, the ASA acts as a proxy device because the user doesn't have an address assigned, so it cannot actually send IP traffic sourced with an IP address because it doesn't have the client assigned in there. It doesn't have a client installed. So source is going to be the ASA's address on this interface in this subnet 136. Let me put in here a bigger box. So the IP header, source is going to be the ASA's 136.1.47.16. Destination, web service address 10.10.10.4.4.4, the loopback of router 4. So that's why they say that the ASA does proxy, because on the protected network, so on the protected network, which is this portion in here, protected resources are going to see traffic, like router 4 is going to see traffic as being sourced from the ASA's IP address, not from the remote access client IP address, because the client doesn't have an IP address assigned. Now, through the portal, to the clientless SSL VPN tunnel, users can access two types of resources. Either published in a portal, those are going to be known as bookmarks, or directly via a native client application installed on the client's PC. Like for example, so either we're going to publish bookmarks in the portal, either the remote user can use the client application on its PC, like for example, let's say, for example, the Outlook client, for example. So it can actually fire up Outlook, and Outlook can connect and grab the emails to the SSL VPN tunnel. So that's the second type of resources that are accessible to the clientless SSL VPN tunnel via a native client application installed on the client's PC. And for that to happen, we have two options, configuration-wise on the ASA: two features, port forwarding and smart tunnels. Now, bookmarks are configurable only via ASDM, because those are stored in flash of ASA in the XML format in an unreadable format. So bookmarks can only configure from the ASDM or the GUI, not via the CLI on the ASA. And we have some natively supported bookmarks, like the ASA can publish in the portal HTTP, HTTPS, FTP, or CIFS resources, or non-native bookmarks which require the use of an application plugin on the ASA firewall. It's going to be Citrix services, RDP, remote desktop, Telnet SSH, or VNC. So what this means is that I can publish in the portal of ASA a Telnet connection to a protected resource, or an SSH connection to a protected resource, or remote desktop session to a protected resource, and then the user is going to be able to click in the portal, and when the user clicks in the portal, a Java application is going to open up on the client side, and it's going to be able to connect via RDP or Telnet or SSH to those protected resources. But of course, as I said, this requires the ASA this requires that you install on the ASA those applications plugins, and only those plugins are supported by the ASA firewall. If you want the user to be able to just fire up on its PC a locally installed client like for example, Putty. If we want the user to be able to open up Putty and initiate some traffic to manage some devices to the clientless SSL VPN tunnel, then we need to provide that kind of access via those two options, port forwarding or smart tunneling. And again, this is a more of a CCNP topic, but just the basics. Port forwarding was the initial version, let's say in order to support native client applications being able to send traffic in the SSL tunnel. So it's an old technology, no longer recommended for a lot of reasons. So it allows the users to tunnel native application connections to the SSL VPN tunnel. One restriction of port forwarding, the most important one, is that it supports only TCP client-server applications with static ports. So applications that run in two sessions or have dynamic port negotiation happening, like FTP or a voice phone call or even a video conference, for example, they're not going to work through by using the port forwarding technology. And then we came up with smart tunneling. So if port forwarding is a way of tunneling applications to the clientless SSL VPN tunnel, and the name, we're going to speak about this in more details in the CCNP class. The name says exactly what it's going to do. It's going to do some kind of port forwarding, but because this is for a lot of reasons not recommended, and because port forwarding did some kind of tunneling, we came up with a new feature which is called smart tunneling. So smart tunneling is meant to replace port forwarding. So smart tunneling can do exactly what port forwarding did, but better, smarter, and it has support for more applications. So it's a smarter port forwarding technology, and one of the main advantages of smart tunneling is that it supports all TCP client server applications, even those which have dynamic ports being negotiated. So FTP is going to work, for example. Now from the configuration point of view, we have pretty much the same steps on the ASA. So first we have to provision the ASA with a certificate, then enable clientless SSL VPN on the ASA, then configure the authorization part, so bookmarks or port forwarding or smart tunneling, then configure the connection profile tunnel group, and of course configure the group policy. Certificate provision is going to be the same as in client-based SSL VPN. So the way the ASA can get a certificate to be used for SSL VPNs is going to be the same options as in client-based SSL VPNs. Then activating clientless SSL VPN is going to be the same way as we did in client-based, as you're going to see. So we have to enable SSL VPN capabilities on that ASA interface, which is used to terminate the SSL tunnels. Then we configure the authorization attributes, but as opposed to client-based, where the attributes were what IP addresses would we release to the clients and what was the split tunneling policy, in here we're going to have other kind of attributes, other kind of authorizations available to authorize the clients how and what traffic to send in the SSL tunnel. So we're going to have to configure exactly what I said before, the bookmarks or the port forwarding or the smart tunnel functionality. In our case, we're going to use only bookmarks using the ASDM or GUI, and we're going to configure a HTTP bookmark. And as I said, at the option, we can also configure other capabilities like port forwarding or smart tunneling. Then we configure the group policy, and we bind the authorization attributes like the port forwarding configuration, the smart tunneling configuration, or the bookmark configuration. Option, just like in the case of client-based, we can use the default group policy, not recommended. We talked more about this in the CCNP class. Then the connection profile, we'll specify the authentication method. We will leave it the default of the local database, and of course we bind the group policy for the same reason, so that when a clientless SSL VPN connection lands on a connection profile, the SA knows what authorizations, how to authorize that session, because it's going to have attached the group policy. Likewise, you can use the default connection profile, not recommended. And the last step is going to be to, of course, configure the username if we use local username password authentication for the clientless SSL VPN sessions. On the client side, is just the client has to open up a supported browser based on the version and based on the code you're running on the ASA. Of course, it has a set of supported browsers and versions which those users should use in order to support all of the capabilities. Otherwise, the tunnel may be successfully negotiated, but data plane may not work. Users may not be able to access resources to the tunnel if they haven't used a supported recommended browser and browser version. And of course, in the end, verification wise, we just go in the ASDM GUI in the monitoring tab to see which clientless SSL VPN sessions are established and what was the negotiated algorithms and the connection profile and the group policy and authorization attributes. And at the CLI, the same command, but now we're saying show me the VPN session database, the details, but for the web VPN connections, not for the AnyConnect connections. Now the command is web VPN. Also, as we've seen on the ASA, when we enable SSL VPN, is the global command of web VPN, because initially SSL VPNs were called web VPNs. So it's like an ancient inheritance of an old command which is still being used. Although the technology has changed its name to SSL VPN, configuration wise, you're going to see a lot of times the web VPN keyword in there.